Okay, so we are starting chapter 7. It may depend on what year you are taking this class as to what you've done prior to today's notes. Okay, so if you did the activity with the making the triangles and figuring out all that, you can just copy these answers down from that worksheet, or I will go in and go through each of these as we go through. Okay. So these are quadrilaterals and other polygons. So the first one is a triangle. Okay, I'm just going to go down the list here. This one we are going to call a square. Okay, this one is a pentagon. This is a hexagon. The next one is a heptagon. The next one is an octagon, nonagon, and decagon. And then down below that, I want you to add in 12 and a dodecagon. Okay, so then we're going to come up here. The number of sides that a triangle has is 3. Then you can go down 4, 5, 6, 7, 8, 9, 10, but then a dodecagon has 12. Okay, so let me show you that. Okay, now the number of triangles. Okay, well, obviously a triangle only has one triangle inside of itself. Okay, so that would just be 1. Okay, if I draw a line from corner to corner here, you could see that it would make 2 triangles. Okay, if I drew a corner in, which you don't have to, but you can if you want, from here to here. Okay, that would be it. I can't connect it to this one because that would make just the side, and same here. So that one is 3. This one would be 1, 2, 3, 4 triangles. So if you notice the pattern, we're going up by 1 each time. So it would be 5, 6, 7, 8, but then it would be 10 for the last one because we skipped 11. Okay. So now think about this. So each triangle is 180 degrees. Okay. So the number or the sum of interior angles, well, the triangle's interior angles only has 1, so it's 1 times 180, which is just 180. 2 times 180, because like I said, each triangle here has 180, so this is 180, and this is 180. So in all, a square has 360 degrees. Okay, then the number of triangles here would be 3 times 180, which is 540. Okay, and so on. You can go ahead and do the math if you want, but I'm going to go ahead and fill this in to save time. So 720 degrees, 900 degrees, 1080 degrees, 1260 degrees, 1440 degrees, and 1800 for your dodecagon. Okay. Now the measure of one angle, and I want you to make a note here that this would be one interior angle. Okay, well, I'm going to take the amount of degrees here, and I'm going to divide it by the number of sides, because that's also the number of angles in that figure. Okay, so it has 3 sides. Well, it also has 3 angles. So 180 divided by 3 is 60. 360 divided by 4 is 90. 540 divided by 5 is 108. Okay, you can follow that pattern. The next one is 120. The next one is the only one that comes out to be a decimal. It's 128.57 degrees. The next one is 135 degrees, 140 degrees, 144 degrees, and 150 degrees. Okay, so now you have that filled in. You can turn the page. Okay, so a lot of this we've already kind of talked about if we did the activity. If not, you can follow along here and you can read that section and it will explain a little bit more. Okay, so it says in theorem 7.1, it says the sum of the measures of the interior angles of a convex polygon is, Okay, what we were doing is we were taking the number of sides and subtracting 2. Okay, so the number of sides, subtract 2 and you get 1. The number of sides, subtract 2 and you get 2. Then we were taking this value here and we were multiplying it by 180 because that's the amount of triangles in each shape. So it's n minus 2 times 180 degrees. Okay, then I want to make a note here to find one interior angle. What we did is we took that sum, which is n minus 2 times 180, and we divided it by the number of sides, which is also the number of angles, okay? Okay, so in example 1, it says find the sum of the measures of the interior angles of the figure. So I have 1, 2, 3, 4, 5, 6, 7, 8 sides, so n equals 8. Okay, so n minus 2 times 180 is 8 minus 2 times 180, which is 6 times 180. Okay, and 6 times 180, trying to find my calculator here, is 1080 degrees. Okay, then it says the sum in example 2, the sum of the measures of the interior angles of a convex polygon is 900 degrees. So 900, and it says the sum of the measures of the interior angles. Classify the polygon by the number of sides. Okay, so what I'm solving for is the number of sides, which is that n variable. So I want n minus 2 times 180, and I'm going to set it equal to the sum that they gave me, which is 900. So I'm going to divide both sides by 180, because right now these are multiplying. Okay, so I would get n minus 2 equals 5. Add 2 to both sides, and you get n equals 7. Okay, well, what is a 7-sided figure called? It's called a heptagon. Okay, and that's whenever it says classify, it means actually to give it a name. So that's why we would name it a heptagon, not just tell me that it has 7 sides. Okay, so let's go on to the next page. So it says the sum of the measures of the interior angles of a quadrilateral is, so it doesn't matter if it's a square or not. If it has 4 sides, it's always going to be 360 degrees. Okay, so it says find the value of x in the diagram for example 3. So that has 4 sides, so I know that it's going to add up to be 180. So I have x plus 108 plus 121 plus 59 equals 360. Okay, so then I need to add those values together, the 108, the 121, and the 59, and you get 288 equals 360. Subtract 288, and you get x equals 72 degrees. Okay, equilateral polygon. Okay, these are all vocab words here. So whenever you have an equilateral polygon, okay, think of equal, and lateral. Okay, like if I do a lateral movement, it means I'm moving side to side. So you can think that all sides are congruent. Okay, remember the word congruent means that they're the same length, and those little hash marks on that picture is what that means. Okay, equiangular. Okay, well then that would mean all angles are congruent. Okay, so maybe not the side lengths, but all of the angle measures are congruent. Okay, and then lastly, I should also mention that that's what that little arc means. Okay, just as a reminder. Finally, the regular polygon, you can tell from both, it's a convex polygon that is both equilateral and equiangular. Okay, so the sides are the same and the angles are the same, sorry. Okay, so example 4, it says a home plate for a baseball field is shown. Is the polygon regular? Okay, explain your reasoning. So I can tell here that I have 3 angles that are the same, and then 2 of them are the same, but they're different than the other 3, okay? And it doesn't tell me anything about the sides, so I'm not really sure anything about that. Okay, so we're going to say not equiangular or equilateral, so not regular. Okay, it says find the measures of angles C and E. Okay, so I'm going to call this X, and I'm going to call this X because I don't know them, but I know that they're the same. And I know each of these other ones is 90. Okay, but I got to figure out what it's all going to add up to. Okay, so I'm going to count the number of sides. So I have 1, 2, 3, 4, 5 sides. So I'm going to do n minus 2 times 180. Okay, so that's going to give me 5 minus 2 times 180, which is 3 times 180. And that will give me 540 degrees. Okay, then I'm going to take what I know. So I have x plus 90 plus 90 plus 90 equals 540. Okay, so I have 2x's plus 270 equals 540. Okay, subtract the 270 and you get 2x equals 270 actually on the other side. And whenever you divide by 2, you get x equals 135 degrees. Okay, so that would be your answer there. If I turn the page again after that, maybe if I can get my page to turn. Okay, last page here of notes. We're going to use the exterior angles now. Okay, we might have talked about them if we did the activity. If not, we can look through here. It says the sum of the measures, if you're looking at theorem 7.2, the sum of the measures of the exterior angles of a convex polygon, one angle at each vertex is 360 degrees. So remember, it does not matter how many sides your shape has. So it could be a triangle, it could be a dodecagon. The sum of the exterior angles will always, always, always add up to be 360, okay? It does not matter. So then lastly, to find one exterior angle, well, then we would take the sum, which is always 360, and we would divide it by the number of sides, which is also the number of angles. Okay, so in example 5, it says find the value of x in the diagram. Okay, so these are all exterior angles, so I know that together they all add up to be 360. So 2x plus 89 plus 67 equals 360 degrees. So in all, I have 3 x's plus, add those two numbers together and you get 156 equals 360. I'm going to subtract the 156, so I'm left with 3x equals 204. Divide by 3 and you get x equals 68. Okay, that's all that they asked for, so we're done there. Example 6, it says the trampoline shown is shaped like a regular dodecagon, so I think dodecagon n equals 12. Find the measure of each interior angle. That's part A, okay? You can ignore this solution, part A. It just had to be in so I could get the picture in there. So for part A, I have to find each interior angle. Well, first I have to find the sum. So n minus 2 times 180, and then I'm going to take that sum and I'm going to divide it by n. Okay, so that would be 12 minus 2 times 180 divided by 12, which is 10 times 180 divided by 12, and you get 150 degrees. Okay. Then it says find the measure of each exterior angle. Well, that would be 360 divided by 12. Okay, well, what is 36 divided by 12? It's 3, and then you're just going to stick on 0. So it's 30. Okay, but notice here, I did my formulas, and I get 130 and I get 150. Okay, if we did the activity, this might ring a bell, that together they should add up to be 180 degrees. Okay, so together make 180, so you know that you did it correctly. Okay, so instead of doing this 360 minus or divided by 12, I could have done 180 minus 150. Okay, or if I knew that both of these were coming, I would probably choose to do this 360 divided by 12 because that was a lot easier. I could do that in my head, 30. Okay, and then I could do 180 minus 30 in my head to figure out the interior angles. Okay, so either way is fine, but those are your formulas that you can use.